Okay, so transmission rebuilds are on temporary hold while I wait for some bushing stock to arrive from McMaster-Carr. So in the meantime, I thought I would do a little experiment to help me determine what the compression ratio of these 1916 Indian PowerPlus motors is. So the overview of the plan is something like this. I'm going to take this cylinder, which is a 1916 cylinder. I'm going to invert it, and I'm going to fill it with a fluid, namely vegetable oil. Seemed like it'd be easy to clean up. And I'm going to measure the amount of vegetable oil that it takes to fill that cylinder to the level of where the top of the piston normally is at top dead center. All right, so here's my, what do they call that, burette, little scientific doodah that I ordered off Amazon.com to measure the fluid as I put it in. I'll flip this upside down, level it on these blocks as best I can, and the way I'm going to determine so what I've done to set this cylinder up is I've got the valve caps on. I've got a spark plug in like I would normally have. I put two valves in. Okay, I don't know if you can see them in there, but there are valves in there, and I've sealed the valves to the valve seats with just a light coat of RTV. Alright, and I had to do this because the piston is actually below the valves at top dead center. So, and so the way I'm going to figure out whether the cylinder is full or not is, or whether it's too full to the level of the piston at top dead center, is this fitting is where the priming valve would normally screw on, and this little aluminum pin right here is what I normally use to set the timing. So I've got two scribe marks on it. This top one that you can see here is a scribe mark that should, this end of the aluminum rod should be touching the piston as the magneto points open. Okay, there's another scribe mark that you can't see, right, that's even with the top of the fitting. Can't see it because of the RTV, but it indicates the location of the piston at top dead center. Okay, so with this screwed in here and tightened up and the cylinder turned upside down, then I'll just have to fill it to the level of that pin inside the cylinder there. Maybe you can see that. And that will be full to the point where the top of the piston would normally be at top dead center. All right, and I'll know the volume of the fluid, and that will be the volume of the combustion chamber when the cylinder is compressed at top dead center. Okay, so I'll get it set up. All right, as it turns out, I'm having to turn the valve myself because my little assistant, who I said was Igor, but her name is actually Desmo Kitty, does not actually have opposable thumbs, so I'm doing the valve myself. This is the third burette load at 50 milliliters a shot going into the cylinder. Probably take a couple more after this. I don't know if you can see that, but yeah, I'm having fun now. Okay, so let's take a quick look at the results of the measurements here. Okay, so test result was 198 milliliters, or that works out to the same as 12.08 cubic inches. Now I got to add back in the volume of that timing pin because it was taking up some space in there. So, you know, quick pi r squared on that and times the length, it works out to 0.05 cubic inches. So total unswept volume in that combustion chamber is 12.13 cubic inches. Now the swept volume, we just used a bore and stroke Another pi r squared times stroke works out the volume swept by that piston is 30.45 cubic inches, which makes sense because it's a 61 cubic inch engine and this is one cylinder of two, so that works out. So compression ratio, add the swept volume to the unswept volume divided by the unswept volume, works out to 3.51 to 1 compression ratio. Honestly, I thought it was going to be higher, 4, 5, 6. I didn't know an engine would run with that low compression ratio, but here we are. That's what I come out with. If you've ever done this or have any information to either verify or refute what I've done here, I would really appreciate hearing from you. I'm interested in that. So, all right, there you have it. Thanks.